Hey, what's up, everyone? It's the Math Nerd. It's my very first video on this channel. I'm actually a pre-med student in my second year, procrastinating on a neurobiology exam as I'm making this video, which is pretty fun. But yeah, um, today we're gonna get into some basic competition math related stuff. Um, kind of rusty, gonna be honest, but we'll see. Basic stuff like what are some tricks defining what this is when we know what that is, when that is a value? So the basic trick here is obviously you want to take the cube of the both sides and kind of see what yields what is yielded rather. So doing this, let's take it step by step. So this is actually going to be x plus 1 over x squared times x plus 1 over x. So then this becomes x squared plus 1 over x squared plus 2 times x plus 1 over x. And then we do another round of distribution. We get x cubed plus 1 over x cubed plus 3 times x plus 1 over x, which, as you can see, um, this is going to give us a value a cubed. Now we remember that x plus 1 over x is a, so just all you have to do is substitute a in there. And now you're going to get x cubed plus 1 over x cubed is, a cubed minus a. So this is a general relationship that you'll find in those types of questions, which is it should take within like 5 seconds once you recognize the pattern, which is always fun. It'll put you miles ahead of other students if you're doing competition math type contests like Me Alpha Theta or Math League, ARML. So yeah. Besides that, there are some other things that could go over. For example, some similarity. These are all basic stuff. I'm not going topic by topic today. That'll be for future videos. Um, so yeah, this is a very common thing you'll see in middle school math. I don't know about elementary or high school math, but it'll probably definitely be in high school math for like in more complex type wording or complex like in a way it'll be more like Olympiad slash like Amy level type question or AMC 10 and 12. You'll see the difference. But shoot, let me draw a shape. So that's a circle. There are many different properties of a circle that are important to know. Let me actually make this bigger. One of the properties is what is the radius, what is a chord, what is the diameter. Obviously, we know what the radius is. It's the distance from the center to any point on the circle. You also know what the diameter is. It's twice the radius. It's a line that is that connects a point on a circle and the point right opposite of it. And then finally we have a chord. A chord, it just connects any 2 points on the circle. So a chord is, in other words, a more broader set that contains the diameter. The diameter is a very specific type of chord, which has special properties. For example, if you draw a diameter, and you decide to draw a triangle, like using another point here. Sorry. One property is that this triangle will always be a right triangle. And it has to do with the fact that the inscribed angle here is 90 degrees. So that's more of a um, that's more of a topic in the realm of arcs, and angles, and all that sorts of stuff. We're not really focusing on that right now. I was trying to focus more on chords. So let's talk about chords real quick. So chords, again, connect two different points on a circle. So that's a chord. Now let's draw another chord. There we go. And there's a special theorem that defines chords, or rather, that can be used to find the length of one part of a chord. And this is called power of a point. And it's derived by proportions or similar triangles. And um, so similar triangles, we obviously know we can if we know that all three angles in two different triangles are equal, we know that those two triangles are similar. So right here we can see. Oh, I did not mean to erase that. Oops. Over here we can see these two angles are equal because they are vertical angles. Okay. Now these two angles, I just said we were not going to use angles, but here we are using angles. So I lied. We have to use a little bit of angles to understand this. So these 2 points right here, A and B, let's say A and B right here, and then we have C and D, right? The thing is, ACB and ADB, you have to understand that they're both gonna always be equal. They're gonna be equal because they are inscribed angles in a circle. It's just a property of inscribed angles. Now it's an inscribed angle because we have those 2 points on the circle, and then we have a third point that is just like that's kind of away from them. It's so like you have these 2 points, and then you have a third point C that's there, and obviously I could draw the central angle. Oh shoot, the central angle is basically connecting the radius and these 2 points. So I could draw the central angle, but what's special about the inscribed angle is that the inscribed angle is half the central angle. So this, whatever this is, let's say this is 120 degrees. This is going to be 60 degrees. Now, remember that I'm a pre-med student and I'm not a mathematician, so I can't exactly tell you why all of this works. I could just throw this out there. Now, if you want to learn why this works, go ahead and go to some other videos like Khan Academy or all that sorts of stuff, or like art of problem solving. I'm just giving out some random tips that might help along the way. So yeah, so we know that these two angles are going to be equal. We also know that these two angles are going to be equal using the same exact idea. And also because the sum of the angles in a triangle are 180. If these two are, are equal to these two, right, then logically the third angles have to be equal. So there we go there. So using that idea, let's say that this length right here is A, this is B, this is C, and this is D. All right. So we can make a similarity ratio here. One thing you have to know is that we always, whenever we're making our proportion for similarity, we're always looking at the side opposite the angle. If there's two sides that correspond to the same measured angle, then we are going to have them on the same like side of the proportion. Like if like we want them both on the numerator or both on the denominator, if you get what I mean. So we'd have C over A, or A over C is equal to, so you'd have A over C is equal to D over B. A over C is equal to D over B. Now again, so this is because C is opposite the double dashed angle. A is also across the double dashed angle. Now, it doesn't matter which side you choose, but you have to be consistent with both. We're going to choose one side from the small triangle, so A, over the same corresponding side of the big triangle, which is C. And we're going to do the same thing, small triangle again, D over B. So D over B. And now, if we cross multiply, we're going to get a very magical, simple formula. A times B equals C times D. Now, this can be used, this is used widely in middle school math, such as math counts, and even in AMCs. So, quite important to know. Yeah, is there anything else? Let's see. Let me think. Let me use my noggin. What about the number of factors? Yeah, sorry, I blanked out for a minute. So I was just trying to think of what I could teach that could be beneficial. So the number of factors in a random number, in any number, positive integer. So that can be found. So number of factors. This is probably going to be the last thing I'm going to teach because I got to go to the bathroom. But yeah, let's do this. So first, you find the prime factorization. Second, you take the powers, you take the exponents. And increase by 1. Then you multiply the exponent, or the resulting powers. And there you go. That's going to yield the number of factors in a positive integer. And why this works, I can shortly explain it, but of course, if you want a more elaborate explanation, go to the other two sources I was talking about earlier in this video. So let's say we had 18, for example. Now, obviously, you could count out the factors. It's not a huge number, but you want to be smart. So using the factor tree, you can clearly see that the prime factorization is not that, it is actually that. So using the idea, we're just going to raise the exponents by 1, 2 times 3, and there we go, 6 factors. Now this is because we use a little bit of permutations involved in here, because 2 to the 1 divides 2 to the 1 and 2 to the 0, right? And 3 to the 2 divides 3 to the 2, 3 to the 1, and 3 to the 0. So what are the different options of factors that we can make? You could either do 2 to the 1 times 3 to the 2, 2 to the 1 times 3 to the 1, or 2 to the 1 times 3 to 0, or 2 to 0 times 3 to 2, 2 to 0 times 3 to 1, and 2 to 0 times 3 to 0. So instead of counting all that, or like doing all that stuff and drawing all the lines, we if you've seen enough combinations before, you should know that we're just going to multiply the two groups, like the number of elements in the two groups, right? So it's going to be just 2 times 3. And that's where this comes from. That's where raising the exponents by 1 comes from. So yeah, that's the end of this video. Hope you found it helpful. And yeah, more videos coming out soon.